Welcome everyone to Personalized Generative Design Workshop. And we're super excited to have you join us. And so maybe next slide, Rajvik. So we're the team from Digital Blue Foam, and we're an AEC startup. We're developing an online platform to do design, looking at the early stage, and also how we can begin to bring in more data to inform the design process to improve like the quality of the built environment. And so we've been basically working on this company for about 4 years, and we're really excited to get the chance to do our first public workshop at CAADRIA this year. So this is a big moment for us. So this is the team. So maybe we can all go through and give like a little bit of an introduction about ourselves. So I'm Sejal, I'm the CTO. I'm a graduate of MIT, and I was working in Singapore as a researcher, and then also then in Dubai as a founding professor in a new university, looking at the intersection of architecture design with other types of design, and looking at how we can begin to build new types of user interfaces and products that work with AI. And I've since resigned that position in the last couple months, and I'm going full time on Digital Blue Foam. And so I'm really excited that the company's growing, and we're able to take the next step with this workshop. So maybe, I don't know, Rutvik, do you want to give an intro?
Yeah. So hello everyone, I'm Rutvik Deshpande. I'm based in India, and I work as a associate data engineer with Digital Blue Foam, and my work focuses on data-driven workflows in architectural and urban scales. I also focus on the research part of AI in architecture. Yeah, Caesar can go ahead.
You're muted, Caesar.
Caesar, you're still.
Caesar?
Yeah.
Oh.
You guys can hear me now?
Yeah.
See my screen?
Mm-hmm.
Okay, cool. I'm Cesar. I'm currently based in Colombia. I'm product designer at Digital Blue Foam. I'm mainly looking at use case applications for different technologies and how we can accelerate the digital transition of the AEC industries. I'm a graduate from the AA MTech program, and I've been working in urban planning, architecture, and at all different scales of the design process.
Amazing. Arifin.
Okay, so before I start, Rutvik forgot to mention one thing, that he's a second-year student of architecture, a bachelor's in architecture. So kudos to him for coming up this big, and he is going to be leading most of the workshop. So yeah, awesome job, Rutvik. For myself, I'm a user experience researcher with Digital Blue Foam, and I'm finishing up my PhD at Simon Fraser University. And my research is improving design tools, and I focused on computational design, human-computer interaction, and information visualization.
Great. And I think what's really cool about our team is we're all over the world. And so the way we work together is really asynchronously and also in a very agile way. So we're constantly on different messaging platforms, texting, and it's somehow we make it work. What happened to the slides? I can't see the slides anymore.
Oh, is it? I think.
Caesar, are you presenting it?
Yeah.
Just okay.
So that they can see your face too. I did that.
Okay, Caesar, can you make your slides full screen? So maybe.
No, just present.
Caesar, just present.
Yeah.
So maybe next, if you feel comfortable, all the participants, maybe just quickly you could turn on your video just so we can just say hi to everyone who's here, if you don't mind. maybe the people in the chat can just give like a quick intro.
Hey.
Yeah. If you're brave enough to say hi.
Hi. Am I audible?
Yeah, yeah.
Yeah, I'll give it a shot.
Hi.
Hi. My name is Akash. I am an architect. I graduated a while ago, and now I'm teaching in a college here in Mysore, in Karnataka, in India. And I was very excited to see the kind of work you guys are doing. But I'm a complete noob. But I'm happy to be here and learn.
That's amazing. Thank you. Anyone else want to say hi?
Hi, I'm Domenico, architect and full-stack generative design developer working in the Netherlands, and very excited to look your product and what you are able to do.
Amazing. Welcome.
Thank you.
Hello, everyone. Can you hear me?
Yeah.
Yes, perfectly.
Hi, my name is Guan Qi, and currently I'm a PhD candidate in the University of Queensland in Australia. And my research includes the data-driven analysis and the digital fabrication and some material computation. And I think it's really a good opportunity to see how to embed the data in the design, especially how to employ the artificial intelligence in the architectural design. So I think it's a really opportunity. So thanks for the team. Thank you.
Great. Nice to meet you.
Okay, can you hear me?
Yep.
Okay, hello everyone. My name is Fauzan. I'm from Indonesia, but currently I'm in Tokyo, Japan. So I'm having my PhD here in Sibora Institute of Technology. My project is on virtual reality in architectural design. So nice to meet you all.
Nice to meet you.
Great.
It's exciting.
Oh, is it my turn?
Yeah.
Hi, morning. My name is Zhong Ming. I'm a postdoc researcher based at the Singapore ETH Center, Future Cities Laboratory. And
Nice.
my research is focused on energy-driven urban design. And now we are working on the tool called Cities Knowledge Graph, which helps urban planners for multi-domain, how can I say, cross-domain master planning support using semantic technologies. So I'm quite interested in knowing how you turn into your work into products, like the startup part. So that's why I'm here.
Awesome. Maybe we can share more on our startup in one of the next sessions and like what we do. That's great.
Okay, cool.
Our company's actually based in Singapore, so our office is in Singapore also. So we're happy to meet in the future too.
Yeah. I saw your address is 2nd Alexandra Road.
Pardon?
Your address is 2nd Alexandra Road, Delta House. Is this the office you're with? Okay, cool.
Yeah. So about half the team is working there. I'm in Dubai currently, but I'm in the process of moving to Singapore.
Okay, great.
Join the team. Yeah. All right. Anyone else to introduce? Do we get everyone?
Hello, I'm Marco from Hong Kong. I'm an architect and working as a design manager in a construction company. Nice to meet you all.
Nice to meet you, Marco. Okay. Do we get everyone? Okay, well, I think, okay.
Yeah.
I think it's very nice to meet everyone. I think we also have some people that are in another time zone, and they'll be like following along the video and also be part of the workshop. But it's really great to see everyone. And also it's like really cool that like the kind of geographic diversity, like we're all over the world. So it's like, it's really cool. Okay, so maybe moving on. Caesar, yeah, so what are we doing in this workshop? So this workshop is based on a kind of question that we were having on our team about what is the future, like what's the next step of all these tools that we're developing using computation. And so what we're really interested is sort of changing the perception that there's going to be one sort of perfect algorithm or one size fits all algorithm that we'll use for our projects. And how can we transition to something called personalized generative design that's inspired by things like chatbots and especially this one type of personal AI called Replica, which actually adapts and evolves over time to the individual user based on what you tell it. And so we were wondering in the future, how could we create design tools that are actually like calibrated to the specific designer? So next slide, Caesar. So this is something we've started to address in our platform. So it's not as evolved as, say, something like Replica, but we're starting to think, okay, maybe there's different types of AI and personas that can live inside of our design tool, that based on what types of problems or the preferences of a user, they're able to change which AI they're using to generate new types of form within our system. And so we're really excited about this idea and where this could go. And also, we're also looking at a kind of like numerical or algorithmic approach, but then also there's a hybrid approach. So next slide, Caesar, that we're also looking at. So this one's like a generator. The next thing we're looking at is sketching-based input. So working with an AI or a generative algorithm through not like inputting kind of numerical objectives, but just through sketching onto a site, having that collaborator be able to interpret your sketches into a building design. So this is another way that we could interact. And so maybe based on the sketching with this tool, the AI also has the possibility to evolve based on a specific designer or like the project phase. So we're really like thinking about these things. And so this is kind of where we're at, but then now we need to like think about, okay, what's this workshop about? So Caesar, next slide. So that's what we're doing. But this workshop is really for you. How can we change the role of the designer from someone who's just using machine learning to someone who actually creates machine learning models that they can use and share online? So we see this as a first step to personalizing generative design. And I'll show you in the next slide what this means. So we're introducing a new workflow that we're developing on our team. And basically the idea is that we want to engage like the computational design community so that they can embed their own machine learning models and algorithms in our platform. So we want to make it super easy. So we have this workflow that we're working on where you can use Grasshopper or some other software to generate data, train a model, and then easily import it into our tool and use it and share it with anybody. And so this is what we're going to do. So we're going to have 3 days. The first day we're going to look at, everyone's going to select like a design problem and start generating some data. Then tomorrow, we're going to look at how we can use the data sets to train ML. And then on the final day, we'll look at how we deploy this online and just start talking about how these could be actually made into applications people can use. Yeah, so this is basically the overview. Next slide. Just some logistics. So just as a reminder, so the workshop will be the next 3 days. We're going to meet for 3 hours each day. We're going to use Google Meet as the primary mode of connection, but also when the workshop's not running, we can all collaborate using the Discord channel. So if you guys are having any questions, problems, if there's something you want to do and want to talk about how you might actually like build it or implement it, we'll be on the chat all day to answer any questions, and we can have maybe meetings between between us, either on the like on a one-on-one or like meet with your team. If you choose to form a team, we can use that via Discord.
And I'll also step in and say that it's better that we use Discord throughout for the chats, because let's say we had an important discussion, there was a lot of texting, but once you close the Google Meet session, you'll lose those texts, so you won't be able to refer to them. So like you can just live chat on Discord all the time as well.
Perfect. Yeah, that's great. So next slide. So let's get cooking, and I'll hand it over to Caesar and Rutvik to take over the next part of the presentation. But I just want to thank everyone for joining, and really excited what we're all going to come up with in this workshop.
All right. Rutvik, do you want to present the agenda?
Okay. So I'll share the screen, or I'll take a look at yours.
No, I can.
Yeah.
It's just right on the, just talk over the slide.
Okay, so the first 20-25 minutes or maybe 30 minutes, we'll introduce the ideas which we worked on, the problem which we faced, the design problems which we faced, so that you can get some ideas on what design problems you might face, or think on the ideation part. And then there are two streams of data generation which we'll be focusing on in this workshop. One is the manual data generation, and one is the visual data generation. So the visual data generation stream focuses on creating data set using Grasshopper 3D. Like you'll create a script which solves the any of your design problems, and will also guide you that how should the script be, which is ideal for the machine learning. So there's a specific format which the ML algorithms take in. So we'll guide you on that. And the other stream is the sketching tool. So you will be given a application which will have a map as the background, and you have to draw building footprints based on different styles, different programs, or say different designers approach. Like we'll also guide you on that. And that will be your image data for your image classification algorithm. So basically there are two streams, to make it simple. And yeah, so that's all. Also, you'll need to present your idea in the last minutes of the today's session, so we also know if the idea is like to be like if we can work on that idea, because as I said, the ML algorithms require a specific format of data, so we can even guide you on how to convert the format which you created to the one required.
And feel free to stop us anytime and ask questions if you're confused. So,
Yeah.
And we also encourage your inputs. Like if you have an idea on how to do something a little differently, we are most willing to hear it.
Yeah,
definitely. And yeah, and another part is that we will be showing you how to generate the visual data in Grasshopper 3D, but we are most welcome if you have some ideas in, say, Revit or any other software which you want to use to create the data to solve your design problem.
All right. So I'm going to introduce one case study we worked on looking at implementing this workflow. And essentially, what we were saying is designers generate a lot of data, and especially with tools like Grasshopper or Dynamo or Beam softwares, we have the ability now to generate a lot of data and collect it. At the moment, unfortunately, we're not really collecting this data, so we kind of, for every project we work on, we lose the data we generate, and we can really not go back to it or use it for the benefit of others. So what we're looking at right now is looking at exploring different ways in which we can use designers generated data to train machine learning models and then use these models for the benefit of others. So here I'm gonna talk a bit about this case study we built. This is based in Panama City, and the idea is that we're looking at improving walkability and improving urban mobility in this city. Panama City is a very heavily car-oriented city, so around I don't know, 30% of the trips, I think, take place by private vehicles. So a lot of the areas and a lot of the land use around the city is dedicated to cars. So as the city continues to redevelop, we're looking at ways in which we could build a parking capacity estimator to help us redistribute or relocate what's currently areas of the city that are currently now occupied by cars and are just inefficiently used in the form of on-site parking or in the form of on-street parking. So essentially, we looked at this neighborhood that has this problem. This neighborhood has a lot of the streets dedicated to on-site parking and on-street parking. On-site parking meaning that a lot of the businesses, shops, and offices have a parking facility right at the end destination. And this makes people take the car more oftenly, and also they don't encourage people to walk around these neighborhoods. So the idea was to look at how we could redistribute all the inefficient parking in this area, consolidate this parking in a specific strategic location, and make people come to this parking and then walk to their final destination. So for this, we used Grasshopper to create a parking generator. The parking generator is based on the designer's parameters. So essentially, we could fit this to the particular specific norms and code of this particular city. And this parking generator will be trained to then be deployed in an application that can be used to estimate the parking capacity for any lot in this neighborhood. So essentially, we can do things like estimate the parking capacity for a new development and see how many parkings we need, where is the best area to position this parking, and how long it's going to take for people to walk from this parking location to their final destination. And we can run simulations, we can create different design scenarios in which we can sort of project what the development of the city will be, and sort of redistribute the parking in the area to a position that will be more beneficial for encouraging people to walk and improving urban mobility. So here we essentially looked at 60 potential parking lots, and we let the algorithm run, which is the image that you're seeing, training on this data. So essentially running on like potential sites, and then that's giving us a parking capacity. Once the algorithm is trained for enough time, then we don't need the generator anymore. We can upload this into an application and then let anyone use this data that someone generated.
Yeah, thank you, Caesar. So the next case study I'll be talking about is the architectural briefing process. We use machine learning to augment the architectural briefing process using the sketching application tool, which you will be using to generate your own data too. So what we did in this was the problem was that whenever any architecture or designer gets a client brief, there's a lot of information present in that brief, right? So before even drawing a single line of any plan or any concept is drawn on the paper, a lot of data is generated just in the brief. So the aim here was to use the uh, client brief data, we were given, or we can even take it from open data sets available, such as say whenever you are given a site, you always have the street on which the site is located, the site area, site perimeter, or the GFA, ground coverage area, or the number of neighborhood buildings. Even if these criterias or the parameters are not given, you can just take a look at them through the open data sources available. So our thought was how to use machine learning to augment this briefing process and create a recommendation system for the developer or the architect, like given the input features. As you can see, the input features we used were street name, site area, perimeter, built up area, built up perimeter, postal code, and number of neighbors, which we analyzed and got this data from the OpenStreetMaps of city of Zurich. And then the aim was to predict the output as the building attributes, building programs. Like given this site, what can be the ideal building program, whether it's good to have a school or a college or a residence. If it's a residential zone, it is good to have a residence or a house or an apartment. Or if it's a industrial zone, it is good to have industries, whether it's good to have a hospital or not, a commercial building or not. So the aim was to create a simple recommendation engine for architects, you can say, where you just input the site information and you will get the uh, predicted building program. And it's up to you, like the AI or ML is not going to replace the designers, but it is acting as a support to human intelligence, and it's just recommending you. It's up to the designer whether he wants to build the hospital which was recommended by the machine. So I can even show you the live example demo of this.
Great. Maybe, okay, so I think now, Rudvik,
Yeah.
it's a good time to go through the demonstration, right?
Yeah.
So just to set up the next part. So Rudvik, you're going to do the demonstration. So
Yeah.
basically we have two workflows. One is a Grasshopper workflow. And then the other is using a sketching app to generate visual data. And so you can choose based on what project you want to work on. You can choose one of the two, but we'll show both how they both work now. And we'll provide all the files so you guys can use that as a starting point and adapt. So once we show the demonstration, then we'll come up with the project ideas.
Okay, so first I'll begin with the manual data generation. We have created a customized application for this workshop. We have been working on this application in our research and development teams too. So what does this application do is, yeah.
Caesar, okay, go ahead. Maybe Caesar, stop presenting your screen. Yeah. Okay.
Okay. So
yeah.
this is the sketching application. Like the background is 815 by 815 15 pixelated map, which is randomly generated. Like you're not going to be given the information of where this map is based on or what is the neighboring buildings programs, but because it is a
wait, Rudvik, maybe first before you get into it, just show the participants the workshop notes so they can follow along.
Okay.
I think I see it on the top of your screen. Yeah.
So we have created a document known as workshop lab notes, and we have shared it to you 2 days ago, so you can go through the entire workflow from day 1 to day 3. So what does this document have? It has all the resources you may visit. You may visit the tutorials, getting started things, or exemplar materials we have provided, like sample files for Grasshopper 3D. And it has an entire guide of how are we going to generate data, how are we going to store it, and then apply machine learning. So for the first day, first part is manual data generation. So if you go on, the first thing is Grasshopper 3D, and then if you come below it, you can see the demo 2, which is generating data set with the sketching tool. So in this demo, we are going to be giving you a website link, which is also provided here. You can see that open link to sketching application. And if you go to that sketching application, you will be seeing a map here, which is randomly generated. You all might have different maps, and there is a polygon button here. And if you click on the polygon, it gets blue, which means it gets selected. So what you have to do is you have to draw a building footprint depending on the neighborhood context, like streets and maps. And you need to double click it to complete. So whenever the polygon gets completed, it's blue. And so the trick here is how we are going to use this for training the ML model. So this is going to be acting as our image data. So whenever you complete your polygon, you can simply click on the download button and it downloads the PNG file, and you can even specify your folder you want to keep that PNG file in. Now, how are we going to make it as a classification algorithm? So basically, what for the very simple exercise is, whenever you download it, you will get a new map. Okay, so a randomly generated map. So what you have to do is, I've specified 3 classes. Like you can even take other classes, but for explanation, I'll explain it via these 3 classes. So the first one is residence, the next is school, and the third one is commercial buildings. Okay, so what you have to do is you have to draw at least 50 building footprints for each of the class. Like draw 50 residential footprints, draw 50 school footprints, and 50 commercial building footprints. Now, how are these going to be different? You need to think upon a idea or a unique feature for each one of them. Like say, my school will always have a courtyard, or my school will always be near the streets. So say I'm drawing a school right now. Yeah, so this will be my school and I download it, and you need to create 3 folders in your local machines, say residence, school, and the third one is the commercial building. And whenever you download this PNG, you need to put that like all the image files in the specified class folder which you have drawn, and make sure that you draw as many as footprints as you can, but the minimum aim should be of at least 50 building footprints, 50 images for each one of the class, because it is always said that the more data you have, the better model gets trained on. More the data, more efficient is the results. So for you to get personalized results, you need personalized data.
So Rajak, so just taking a step back, what is the type of machine learning problem we're working on here in this example?
We are working on the image classification algorithm.
Okay.
And what it will do is the machine recognizes the patterns in the images. The machine will not be given any other things other than the labels, like the schools, residence, as well as the commercial buildings. It will just be given we'll just give them the machine's label and the image. So what image classification?
And if I have a different idea, so say if I don't want to do building footprints, can I work on that? Or do I have to use this application?
Yeah, so as I said, like the basic approach I'll explain is through the building programs. And if you go to the Miro board, you can see different ideas. Like the building footprints can be based on a designer style, or it can be based on different city style. Like say New York City's building footprints are different than Zurich's, or it is different than Singapore's. And it can also be based on era such as Gothic, Renaissance era footprint based on that.
I think also it's just good to add that like you can use this app to generate your images for this algorithm, but if you want to use Photoshop or another software, you can also use it. So we're just showing an app. Also, if you have an idea for a new type of app, we're happy to like work with you, and maybe we can help you like build a drawing app related to your project. So this is just to get like an idea of like what you could do. Yeah.
And also make sure like whatever classes you are drawing, say the residence or the school, you have a unique feature in each one of them so that machine recognizes it properly and it doesn't get confused because all the footprints are of similar types.
Yeah.
Yeah,
Cool.
so that's all.
Is there any questions about this demonstration from the participants?
Yeah, I just had a thought.
Yeah.
So I can use any software to create a footprint, right? And I need to just save that as a PNG, but not as a JPEG.
You can save
Only
it as a
PNG.
JPEG as
Anything
well.
No
image file.
Either of these.
Yeah.
Okay.
I also have a question. Does the scale matters?
No, the scale
of
just draw according to the neighborhood context. As of now, we are not going to go in the detail of scale or the dimensions, creating a simple building footprint based on the neighborhood just to start with. And in advanced stages, you can of course add dimensions and scale to it.
I think though the background images are all the same scale.
Yeah, they're all of the
right?
same scale. Yeah.
Yeah. So it's all relative in this one.
I have a question.
Yeah.
Aside from the label, school, residential, or commercial, do we need to draw like each footprint with a certain characteristic? I don't know, as you said before, courtyard or L shape, in order to give the machine some criteria to train?
Right.
Yeah.
So make sure like
Okay.
each class has some unique feature. I'm not saying that they all should be similar, but they should have a similar feature. Like say all the buildings have all the commercial buildings have a courtyard in them, or
Yeah.
all the residential buildings are away from the streets to avoid the street noise, or to avoid
Yeah.
the
Or even like say if you wanted to do like Zaha style building, so you use like splines instead of a polyline.
And what about cheating? I mean, if, for instance, in the school label, we always draw L-shaped building, and then we just put inside some circular one to just confuse the model. Is that something that it can help? It's like lowering the performance.
Feel free to try it. Like this is all an experiment. So if you want to try to break the algorithm, that's also.
So tomorrow we'll also see that how to fool the machine. So like you said that all the schools are of L shape, and then you provide it a circular building. So the machine can get tricked, and it might show you less performance, like less accuracy to predict the building program or anything like that.
Clear, thanks.
Cool.
Do the building footprints need to be of a certain polygonal shape, or can they be organic? Let's say I'm using iPad to sketch and I'm using concepts.
Yeah, no, we would love to. Yeah, no, like feel free to try. Actually, maybe we can also provide just the background images, Redvic, in the folders. So if you want to bring it into iPad and just sketch on top of it.
Also make sure
also can.
The other thing I forgot to add is that we have provided the site in the center of the image. So make sure you draw near the center of the map, because then it will be easier for machines. Or else if you draw something on the corner and the rest all the buildings in the center, then again the machine might perform poorly.
Can you explain that? I didn't understand that very clearly.
So the blank site which we have provided is actually at the center of the map, and make sure you draw not exactly, but somewhat in the center of the map, instead of drawing somewhat like in the corners or edges of the map, or else the machine might get confused.
Yeah.
Okay. Yeah, got it.
Great. Any other questions?
If you want to use any other software, I'll just add a folder which has all the map backgrounds.
Yeah.
Is it okay?
Super. Any other questions? So we can go to the other example.
Yeah, I have another one, a quick one.
Yeah.
Now we are generating this picture, but what about getting the picture from the real, I don't know, Google Maps? So is that, I think, applying the same way? So we just need to extract the Google Map picture like within a certain size and try to collect them together and train the model in that way.
You can even do that, but for now, to keep it simple, we have used the OpenStreetMap data. So we have changed the color of buildings as well as roads to black and white, so it's easier for the model. But of course, you can use the satellite images as well. But the only point is that satellite images will have a lot of colors and a lot of elements in that single map.
So we need to pre-process the data, the image data. And
Yeah. Right.
Maybe in Photoshop you could like threshold the image.
Yeah.
So we're actually doing something similar to that. So we're using the OpenStreetMaps data to train an algorithm. So we're taking like footprints from OpenStreetMaps in one of our experiments to come up with a way of generating new types of footprints based on typologies. We're not showing it, but that's something we're looking at
Yeah, yeah.
also.
So we are actually, with this application, we are
Yeah.
eliminating the step of pre-processing, because pre-processing generally takes a lot of time cleaning the data
Yeah.
and making it to the format of whatever you need.
Yeah.
So of course,
I mean,
that's an option.
Another too is like, say if you found like another data set of images, using that as an input. So you just place images from like clip art as building designs could also be an option.
Yeah.
Clear.
Cool. Okay, so maybe we can just show the other demonstration. Caesar, are you doing it or Redfig?
I think Radvik will show the daylight. I can after quickly show the parking that we added to the examples.
Okay. All right. So that was the sketching app. So say if you have a total new, the sketching project might be a good one if you don't have coding experience, but also if you have coding experience, I think it's also super interesting. So that's one possible project. The other is using a Grasshopper workflow, which Rudvik and Caesar will now show.
Yep.
And you have all the notes for how to do these exercises. It's in that document. Was there a question? Or you could, I was just thinking, or you could also just try to do both.
Yeah, definitely.
You might have enough time to try to do both.
So we are also explaining two machine learning algorithms with these two streams. So of course, it's good to try both practically.
Yeah, yeah.
Okay, so if you again go back to the lab notes document, the first part of day one was generating the data visually through Grasshopper 3D. So I'll explain what and how we are going to generate the data. What are the components in Grasshopper we are going to use? So the prerequisites was to install Ladybug. So we are going to use a Ladybug component called as Ladybug Fly. What it does is if you provide the input parameters to the input sliders slot, it will, and when you click on true, it will start generating data. I've written all the notes in the script given.
Wait, Rudvik, just taking a step back. What does this code do?
Yeah, so I'll explain
What is the design?
What was the design problem and
Yeah,
how I use the script. Okay.
Maybe explain that first before going. Okay.
So the problem I was facing is I wanted to design a room, and I wanted that room to have maximum daylight. But the issue I was facing is where do I provide the window opening, say on the south facade or north facade or west or east, and what should be the window to wall ratio, how long should be the room, what should be the breadth of the room, the height of the room. So I jumped into Grasshopper to solve this problem, and I created a script in which I provide a like this is the simplified version. If you go to the longer one, double clicking on the cluster, you will see all these steps here. So what it does is I designed a parametric room, which had the input parameters such as height, length, and breadth. Then I created a window to wall ratio and provided a facade opening on the southern facade. I chose the city as the city of Mumbai because that's where I needed to design that room. So Mumbai is based in India. And then so that was the idea behind this script, to get the daylight autonomy. So what is daylight autonomy? Daylight autonomy is the percentage of time above which the daylight is above the specified target illuminance, the threshold illuminance, right? So it's always better to have more daylight. It's better for the occupants, it's better for more productivity of occupants. So I'll just let you know how do I generate the data out of this script. So now you have any idea of yours and you want to create or generate the data. So let's dive into that. The idea can of course be of yours. I just provided a basic idea of mine. You can, if you're total newbie, you can just follow along my Grasshopper script. which will be my idea, but of course you can have your own idea too. So what we'll be using is Ladybug Fly, as I told, and we connect all our input parameters to Ladybug Fly. So the approach here is to generate numerical data, right? So how do we generate numerical data, and what is the ideal format of data required for machine learning? So I think comma separated values act as the best format. Like if you go to any machine learning project, 60 to 70% of the projects are based on comma separated values. So how do you generate comma separated values based on your Grasshopper design script? You will be connecting all your input parameters as well as the output parameters. So you can see the input parameters was the geometric dimensions of the room, and output parameters is the daylighting, average daylighting, daylight autonomy, which I connected to a concatenate component, which is present in Grasshopper. You should connect the input as well as the output parameters alternately, and the other alternate uh, slots should be filled by comma. So that's where it comes from, comma separated values. Each of the value is separated by a comma, and make sure you add the output parameter at the last, because then it would be easy for you to split the input and output parameters for machine learning. So what machine learning does is you give in input and you give in output for that specified input, and then it recognizes some patterns and trends, and uh, makes some relations between input as well as output. So it's better that if all the input parameters are first, and then you have the output parameter separated by a comma value. The next component we use to generate to record the data is the data recorder, and you connect this to your panel. So the panel will be your final panel, which will have something like this, which has all your input parameters depending on how you have connected them. Like you'll have 1, 2, 3, 4, and the fifth one is the daylighting one. So if you follow along this script, you need to click on true. You need to attach a true button to your Ladybug Fly for the script to get started, and you will see something like the screenshots of whatever messages you will get. I have provided in the lab notes, where they ask you whether to continue, because if you by mistake started, it will take like lots of time. And this is why I chose machine learning as well, because Ladybug takes a lot of time to calculate the daylight autonomy. So I basically kept this script running for 6 to 7 hours to generate a good amount of data, and then I use machine learning to find another output for given input.
So one point that is worth mentioning here is that the advantage of using machine learning for an exercise like this is that simulations usually take a lot of computational power and take a lot of time. So a faster way to estimate or predict what the say simulation result would be is by using the data that you've already generated from previous simulations to train one of these models, and then you don't have to go back to your simulation and wait and spend the computational power that it would take to run a simulation for a given case. Once you have trained with enough data one of these models, then you have a good percentage of you have a good chance to estimate the right value for any further exercises that you do. And what we're interested here is not to lose this data, but capture it and train these models so that you can also share this information with others that are not training in machine learning, or do not have the expertise to create one of these simulations in Grasshopper, let's say. So if you're working in your office and someone needs to run this model, they don't need to know Grasshopper anymore. You can just use the pre-trained machine learning model, and they would have a good estimate of the results from a simulation like this one. Let me share my screen and I'll quickly go through the parking generator.
Yep. Also, I'll just briefly summarize the whole process of generating data in Grasshopper. You basically need three main components. One is Ladybug Fly, which acts as a data generator. Then you need a concatenate component, which creates comma separated values using comma. And then you need data recorder, which connects to the final panel from which you can just download the data as CSV. If you right click on this, you will get copy data only, and when you do copy data only, you can just simply paste it in a Excel file. The steps I've provided. I think I'll show it after Caesar shows the parking application as well. So the first thing is data creation, and then I'll also show how to store this data on your Google Drive.
Right. Are you guys seeing my screen?
Yeah.
So for this was based on the same case study that I showed earlier. Essentially what this generator does is that it takes any outline that you can draw and it solves sorry, it's important flip. It solves a parking layout within these outlines. So you can modify this outline and you would get an updated version of the parking layout. So the idea here is that if you guys, this is set up as similarly as the example that Rodvik just showed. And if you double click on this cluster, you would get access to how the definition was constructed. And you can also look in detail what's happening to generate the parking layout. But basically any definition or any Grasshopper script that you can come up that has a clear input and also one clear output. So in this case, it would be the building footprint and the number of parking slots that are generated for each iteration of the building footprint. So here we have the clear input, which is any line that I draw to launch the generator, and how many these numbers that are changing as the footprint changes. And essentially up to here is where most Grasshopper definitions end. What we're trying to do is capture this data and store this data in a way that we can use it to train machine learning models further, and then share this information with other people that may not have the ability to or the expertise to create these generators in Grasshopper.
How do you Caesar?
Yes.
So do I have to manually change the shapes to get?
No. So
how can I automate this?
One way to generate this would be, to draw like similar to the sketching app. You would draw like thousands of different layouts or outlines until you've recorded enough data samples. But here we have also provided this random generator, which what it does is that you can just simply connect these points to this curve instead of you inputting your own curve. And what this is doing is generating random points and creating polygons out of these points. So here there is another component for this. You need to have Kangaroo installed, but I think for the later versions of Grasshopper, this comes included already, unless you have something that is before Rhino 6. So Rhino 5, you would have to download the plugin. But you would simply trigger here set this to true and trigger the counter. And then the random points is going to start generating just different layouts for you. And as that happens, then you start recording all these data that you would later use for training the model. And I guess this could be anything. You could think of building up an algorithm that calculates or estimates how many seats in a restaurant can fit in a given space, how many shelving space in a commercial supermarket, how many units in an apartment building. Or you can also, another project.
From the previous example of the daylight, I saw that basically you're making all the permutation, all the combination of the input, basically, right? In the CSV, I was noticing that you were generating all the possible combination, correct?
True. Yeah.
And I try like something very similar using like a genetic algorithm like a Galapagos, but it was not doing all the combination possible. So what did you implement to have this kind of you know, to have all the combination possible of all the sliders that you create?
Okay, so I think you can still see my screen, right?
Yeah.
Yeah.
Yeah. So whatever input parameters you have, say for now I had the X, Y, and Z of the room, so geometric
Mm-hmm.
dimensions. I connected all these parameters to a just wait. Yeah, so I connected all these parameters to the data generator component, which is Ladybug Fly. So whenever you connect the input parameters to the input sliders and you click on true, it will give you an option of iterations, like all the possible iterations it will go through. So for this script, if you run this script, it has around some 128 or 1128 iterations. So that iterations are all the combinations of input parameters which goes in.
Yeah,
So,
clear.
so it's a ladybug script.
Yeah.
Yeah, I'm not used to Ladybug, that's why I asked, so
Yeah.
I should know about it. Sorry.
Perfect.
Yeah. Okay.
Great. Okay, so maybe any other questions? So if you have any questions about the Grasshopper file setup, we have all the instructions in the lab note of what Rajvik just described, but also we'll also be online all day. So if you have any questions, we're happy to help you out with that. So maybe let's go to the next part of our presentation, which is the idea generation. So Rajvik, maybe you can share the slides.
Yeah.
Okay, so so the next part, I think quickly we all just need to kind of select a project or problem we want to work on for the workshop. So here are some possibilities of things you could look at. I think though in hearing everyone's interest, everyone has like a topic that they're probably like want to explore. But some we thought about on the team are style and form, the envelope design, net zero construction, real estate, or 15-minute cities. So the first step is kind of think, you know, what's the big idea you want to address with your project? And then the next part, if Rajvik, you can go to the next slide. Basically, we need to design the problem. And so basically for any ML setup, we need to think about two things. What are the input parameters and what's the output or the prediction? So once you have your kind of big problem, then you can think, okay, what are the kind of design inputs that I want to look at, and like what's the output that I want to measure? So here are like a bunch of possibilities that you could look at. And so yeah, so I think maybe the next step, I forgot what's the next slide. Okay, yeah, so next step, I think everyone has access to Miro. So maybe Rajvik, can you open up Miro?
Yeah.
So we'll just like take a little bit of time, I think, individually. So the first step, it's like a 3-step process. The first step is to customize your name tag. So go down, yeah. So this is where we're gonna like kind of work. So you can customize your name tag and then go down. So this is just like the simple like ideation process. So if you zoom in, like zoom in on mine, Rajvik. So you just need to fill in these questions. So you say, hi, I am Sejal. In my project, I will, and then you can say, okay, I said I want to detect the style of the building from a sketch using generative data by sketching, using a drawn building footprint as input to predict style as output. So you just need to fill in these cards. I hope this is clear, but if you just fill in these cards to answer those questions, you'll have a problem statement that you can solve with ML. So maybe we can just take like a 15 minutes to sort of ideate. And if you want to do more than one idea at this point, that's also totally fine. But I think now in just Miro, we can kind of see also what everyone is interested in working on, and maybe if there's possibility to work together in teams, or like maybe we can subdivide like where you have your own project, but you're working on a similar type of problem, so we can like you can work together and collaborate. Is that clear to everyone? Any questions about the ideation?
Also, the data generation can be a long process. It's not limited just to the workshop time limits. You can take your whole day. The sketching application will be also available to you, as well as you can go through the sample files, and you can take as much of your time till tomorrow to come up with your ideas as well as your data.
Yeah. Erfin, is there anything else we should add?
No, I think we're good here.
Okay, so let's just take like a 15 minutes for everyone to get into Miro and fill this in.
Also, we have the examples here for the sketching data generation and Grasshopper data generation. So like we said, manual sketching can be based on the classes can be different city styles or era styles or different designer styles, say Zaid's footprint or Ramkula style footprints. And the Grasshopper data generation is solving a design problem using your script.
Okay. Okay, so let's just check back in 15 minutes. All right?
Yeah.
All right. We'll be here if you have any questions.
Yeah.
So maybe we can keep going with the idea generation, but maybe if everyone's like not too shy, like you can present like the ideas you're thinking about. So we can just go one by one. So does anyone want to present their idea?
You can even just let us know what idea you're thinking on.
Yeah. How about Domenico? You have a lot of ideas. A lot of great ideas. Yeah.
Well, can start with the first one.
Yeah.
Yeah, basically in the first one we have a plot, and we have like you have to consider like 3 different kind of houses, like Lego blocks. And the point is with a fixed density, so I need to serve, I don't know, a certain amount of people, and so the sizes of the houses of course are different. I want to find the best program, the best combination in order to have affordability level very high, and I want to know like the total surfaces and the total price.
Right.
So try to find out the program. The second idea is about a typology. So imagine we have a polygon in which we can inscribe the not like a square courtyard typology made up of row houses, and of course you can combine those in many amount you want. You can make a row house long 50 meters, or you can make in 50 meters you can make 5 of 10 meters. No? So my question is, how can we make like a segmented courtyard? So the size of the row has to be kind of equal or balanced in order to look good, even if we have like a weird shaped polygon. That is the second one. And the third one is, if you look at the city, and there are like some plot that that the municipality is going to use for development. and we want to find out how, for instance, two objects like two towers of a fixed size can fit. So we have to find the best plot for those towers. Putting, I don't know, constraints from the boundary and distances between each other. Maybe one plot is too thin, the other one is too wide.
Do you have like a Grasshopper script to address some of these problems already, or do you have to make something?
I have one that is the combination, the first and the second, but it's too big, and unfortunately I cannot share it because
confidential.
From the company. Yeah.
Cool.
So maybe I can try to make a simplified version.
Yeah, I think it's super interesting. There might be a possibility also of combining the Grasshopper with the sketching. Like if you could export images from Grasshopper and use it with the sketching app, this is also a possibility. Just thinking out loud. So maybe we just can have a thought like how you can achieve these goals.
Okay.
Rutwig, Caesar, do you have any feedback on it? Like how might we?
No, it's actually interesting ideas. How you are connecting the surface with affordability. But yeah, that's also a trick to create a Grasshopper script out of it, which will have certain input parameters, and then you have the output parameter. But I guess you'll find out a way.
No, I was thinking if you do have a Grasshopper script that addresses some of this, you could just, for the purposes of this and just training the machine learning model, you can just build a simplified version of it where you know, like you could later on just train it with the one that you can't really share with us, but just so you learn the whole process and then experiment with different models in terms of accuracy. And I guess for that exercise, it would be better to start with something simpler, but knowing that like you can build on it later on. So that was the case of the parking algorithm. Let's say I simplified this to.
Caesar froze.
Yeah.
he was about to tell you the secret and then it froze. I can hear you now, Caesar.
Can you hear me now?
Yeah.
So yeah, with the parking algorithm, the actual Grasshopper script at the beginning had a lot of parameters and was quite predefined. But for the purposes of just testing out the machine learning model, I simplified it a lot to, some basic inputs and some basic outputs. So that like we could test out the accuracy of the different models. So maybe for this, if you already have something, you could try it first with some simpler version, and then on your own later on you can try the same model with your entire definition.
Yeah, sure.
Awesome.
And you can even minimize some input parameters. For the daylight autonomy idea, what I had was the direction of windows as well as the window to wall ratio. So the window to wall ratio, I defined it in a certain way, like 0.4 to 0.9 will be the range of parameter, and I just focused on the southern facade. So you can just minimize the number of parameters in this way. Instead of having like lot of parameters, you can create a range of certain parameters and fix certain parameters as well.
Clear.
Great. Okay, who's next? Who's next brave enough to share their idea?
Maybe I can go next.
Oh, fantastic.
So I have two ideas. The first one, I just want to have fun here. So the first idea is to predict a suitable building location. So like when I have a sketch, a building footprint sketch, so I can predict where is this building suitable to be placed, whether it's in a certain city or certain geographical location, like whether it's a hill, a mountain, a beach, or etc. And that's for this first idea. The second one is much more practical, which is predicting a landed house price in a city. So we can predict based on the building footprint, whether based on the range of price, whether it's cheap or in the middle, or whether it's expensive. So those are my ideas for this workshop.
It's great, actually. The building location one is quite interesting because, as I said, that each city or even each region has a certain uniqueness in the building footprint. Say, if you go to Hong Kong, the buildings are more dense, whereas if you move to some parts of rural Europe, they are like more far away from each other.
I think for the house price, you would need to have a record of the house pricing, and that can be tricky. So unless you have a data set that you know, like the locations and the features of the house, and also what the price is, it would be difficult. What you could do though is simulate the predicted price, the house prices, and train the model, and then just learn what the process is for later on, for when you find the actual data set with house prices.
Actually,
because for this prediction particular,
I know a data set which is of Boston, and it has like, I think, 2,500 houses with some parameters as well as prices also. So I can just add in the link and you can download that file from there. It's actually a CSV file.
It would be great. Thank you, Ritwik.
Yeah.
Exciting. Okay, who next? Who's next? Who wants to share? Maybe Akash? Is Akash here?
Yeah.
Yeah.
So I'm still formulating the second one in terms of the output, but okay, so I have two things that I'm thinking about. One is to figure out a combination for built versus open spaces in terms of footprints for a, let's say, a housing project. And I'm just guessing, I don't know whether sketching would be a good way to go about it or Grasshopper, but perimeter and building volumes and car park would be some of the criteria that I would like to put into, say, try and figure this out. And the other one is for a public building, maybe in a dense urban environment. This I was thinking of doing through sketching and using Google Maps or OpenStreetMaps to kind of predict a location for a public building. But yeah, that's the idea.
Fantastic. Feedback from the team?
Yeah, I just wanted to jump in and say something. Yeah. I mean, it's cool that we ideated, and good job, everyone. But I think part of the challenge of generative design or computational design, that is to make design computable, is the problem formulation and abstraction. I don't want to go into design theory, but when we have design in our minds, we're like also changing the problem formulation. But when we make a Grasshopper graph, or we, I don't know, like create the 3D model, the design problem is pretty much formulated at that stage. And then for parametric modeling, it's abstraction of inputs and outputs. So to able to have machine learning work, predict properly what we need to predict, I think like it's a good idea to have clearly defined outputs. So like some of the terms, like you might think about breaking them into something that is more measurable. For example, like suitable functional open spaces, like what is suitable? How do you define suitable? So let's work on that. I mean, it's always going to be a work in progress.
And yeah, and I think that's like always also an interesting question. These kind of metrics that are hard to measure or sort of qualitative. So I know like a lot of companies and architects have like a sort of secret formula to measure something like that. So we can we can think, what is that formula to measure what is suitable and give it a number. But then that's like, yeah, that's a secret sauce.
So maybe that could be, say, number of users versus amount of space, or say a volume occupied by per user.
Yeah, and you could take on all those metrics, apply it by some sort of ratio, like a weighted score, and then that's your like.
Could be a ratio of, let's say, for that in particular, this total open space. If you're looking at housing, for example, then you could measure what percentage of open space in relationship to the built area of your building. And if you want to go further, you could say how many inhabitants or how many residents a building can have. So you can have a measure of green space or open space per person. So whatever design is giving you more, it's the one that would be more optimal.
Okay.
Great, thanks for sharing. Okay. Who hasn't spoken? Gao, do you want to present?
Oh, I'm very sorry. My English is not very well, so it's sorry.
No problem. Or maybe we can help you through it. Yeah, how about that?
Okay.
So you're looking to develop a personalized architectural proposal, specific needs, using the sketching tool based on educational information.
Yes.
To propose a kind of typology.
Yes.
What type of educational information? What do you mean by that?
Because I want to build up a modeling for children, where it's very far from our country, and they lack book and education information. So I want to build a model which is good for there, and it's based on the actual size, what they lack, and what they need. So we design this information, we can build up, we can have some information, education information. From this, we can based on their need what book, and the book is come from where, so we can certain the function. Next, design function, we can make a module block composition. That's all. Thank you.
Thanks, Gao. That's super interesting. So what I understand is you're looking at, okay, how can we plan better educational spaces based on, say, not only like the footprint of the building, but also maybe like planning amenities, something like that. Does the team have any feedback, any kind of thoughts how we can help Gao, like help craft her problem, or like the kind of data that she could use as an input?
Hey, so the first thing I want to say right off the bat is that we're all English as our second language here, except maybe Sejal's. So at any time, if you feel like you don't understand us, please stop us and ask us. And I guess it's got less to do with, formulating the design problem is hard. So I think if you have trouble defining that, what you can do is think of like 3, 4, or 5 sentences. I want to be able to do this because of X, and then Z or Y. Like, like try to break that down into sentences or even single words, and that will kind of help you formulate the design problem. So let's start with that. So what Gao just told us, like if you could, instead of educational information, like from what you said, put down 5 phrases or 5 words which you think are most important. I think we can start with that.
All right, thanks, Gao. Let's okay, I think we have a couple more. So Guangxi.
Hi, I'm here.
Is that how you pronounce the name? Guangxi?
Yeah, it's right.
Perfect. Okay, let us know your project.
Yeah, okay. What I want to do is to predict the house price, the relationship between the house price and the surrounding environment, and the street view. So, for instance, I believe that there is always a reason why some house was sold at a high price and some house was sold in a low price. I think maybe it's because some house has a close distance to a prestigious school, or maybe the house has a really good street view, or it's close to a natural park, or some other reasons. So when it comes to the data, I want to achieve it from the Google Maps. So so I can use the Google Map, the street views from the Google Map to do some analysis using the image segmentation, such as the PSPNet is a quite easy machine learning model that can help me to divide the model into several parts, so that I can count the pixels of the green parts, the sky parts, or the road parts, so that I can. So it's just a kind of value, so that I can give each picture a score. So I think it's quite a lot of data I need to achieve. So I need to download a lot of data from the Google Street View and analysis it. So actually, it's part of my current research. So I have some data about the sold house price in Brisbane. So maybe I will try to combine them together. So to find all in all, my conclusion is trying to find the possible relationship between these two things. So okay, another thing is I want to try to do some form generation, because I was so impressed by your website online presentation system. I don't know how to say it's I really want to try it, but I have no idea about how to do some quick demo or quick Grasshopper in a short time. Yeah.
We can have a discussion about that. I think like one-on-one we can like talk more in detail, like how you might go about that. But the team, do you have some feedback for Guangxi?
I mean, from what I understand, you already have done some work in collecting this data, right? And you know how to assign a price to these images, or you're segmenting this image in a way that can help you score it, right?
Yeah.
I want to add one point, like you already have the data of the relation, right? The prices as well as the street view. So you can add another element which can give it a personalized touch is, okay, what according to you, like, do you like this building based on the street view, or what price will you be giving for that house? That can be an interesting twist in this.
Yeah, I think the other thing I was wondering too is like how could you take this model and make a user interface out of it, and like what would that look like? So I'm not sure if that's something you're interested in, Guangxi, but also like the user experience of this new tool you're thinking of, like what that could kind of look like. How would they interact with the algorithm?
Yep. But the other thing you could look at is other reasons why the price is whatever the price it is in terms of what the build form is. So apart, what are you using to classify the view? Just like so, sort of like how much open space they have, or what the quality? Because if it's with Street View, I imagine you're looking at like sky view factor or or instructions in what you see in the image.
I think this is like interesting because he could, Guangxi, you could use the kind of idea behind the sketching tool. You could just bring in your own images and then have the user just score them based on different criteria, and then use that as the tool so that it can predict for other images metrics.
Yeah, I know it. There's I know the price has some relationship with the area of the house, so it's not the street view is not the only reason about the price. So maybe I will try to do some do some sketch to draw the boundary of the house. Yeah.
Cool.
Yeah, thank you.
Great. Okay, I guess Zhengming.
Zhengming, correct, yes. So I have a simpler project. I just want to categorize the street block. I would like to categorize the street blocks based on their building footprint type, which means each street block can contain multiple buildings, so different from the in the app you showed just now.
Yeah.
I would like to recognize the building as a whole together within a single street block. So I imagine I will have several Google Map satellite views, and I train the model. Like I tell this is a courtyard, this is a podium, and that is the tower. And then I would like to categorize more street blocks like into categories based on their footprint type.
Interesting. Yeah.
Yeah, I think it's like super interesting. But what would the categories be, Zhengming?
Like categories, for example, podium, where there's a huge volume. I mean, like extrusion of the podium, and then or a courtyard if there's like 4 buildings combined together making a courtyard, or like multiple towers inside. Yeah, things like this. Yeah.
Actually, that's super interesting. I think what I was thinking too is like how different cities have certain typologies. So like you could have a category like the Amsterdam typology or like the Vienna typology. So it could be like even more specific than just like podium or L-shaped. Like it could be very specific to like a type of city or a style.
Okay, that's a good point. I was thinking for the same city, maybe there are different neighborhoods that have different types. But crossing different cities will be also fun. Yes, thanks.
Yeah, when you first described it, I also thought about that you could potentially use cities that have a particular block structure. So let's say Barcelona, New York, Berlin, and even if you just run those 3 with the sketch application, after you've trained those 3 data sets, you could draw any new footprint, and it would tell you this is a Barcelona building building type. This is a New York building type.
Cool. Oh, that would be fun too.
Yeah. Great. So I think those are a lot of amazing ideas. So I think now, maybe the next step, I think that like kind of takes us to the end. We won't force it, but if you guys see like someone else you want to work with, have similar ideas, and you want to work together, we would encourage it, but we won't force it. And so I think the next step is just to get your hands dirty, to start working through the example files. Like, I think the first step is just to try to do the examples in the lab. And then the next step is to try to start thinking, how can you begin to adapt your concept and abstract it so that it can be executed with the sort of framework we've developed. In the meantime, we'll be on Discord all day. So if you have any questions, feel free to reach out. We're also happy to have a chat to talk about like your specific design project and how you might build it. But I think it's good first for you to do the workshop, like the demonstrations, to have a good like kind of understanding of what you need to do, and then we can go from there.
Also, if anyone requires a reference data set like I provided for the prices, so actually that's someone else's data, but I know a lot of such kind of data sets, so you can just ask me or even write that I need this data in your Miro board about your idea, and I can try to fetch it. But the aim is to create your own data.
Yeah. Anything else to add, Caesar or Arifin, before we wrap up?
I don't have anything to say. I think it's all good.
Okay, so
for those, for those that have experience with Grasshopper, who have done ML models in the past, they can just start straight doing their exercises. That's just as a reference for those that are new. They can just follow up, and that would clarify a lot of the questions that you may have here in terms of how do you define an input and how do you define an output and what we mean by that.
Yeah, and I think, oh yeah, and like maybe one more thing is like tomorrow we got a couple of questions about showing our platform that we built. So we're happy to talk a little bit more of like our product and like building our company and answer any questions about that. If you're also thinking, you know, how might you take your like research and take it into a startup, we're also happy to have a chat about that at some point during the workshop. Because I know I was always thinking about that when I was a researcher. You know, how do I make this into a business? So we'd be happy to have a chat about that too.
Okay, that'll be great. Thanks.
Yeah, I mean, I think also maybe we can give them a trial, Caesar. We can give them a trial. So maybe we'll share that with you in a bit. We'll share your link so you can try Digital Blue Phone.
Okay.
Awesome. All right, guys. I think that's it. So we'll see you on Discord, and then we'll meet back at the exact same time tomorrow to do step 2 of the workshop.
And all these steps are elaborated in the lab document. But if you need anything apart from that, or any step is unclear, you are stuck at any step, you can definitely message us.
All right. Bye, everyone.
Bye. Thanks.
See you tomorrow.
Hey, thanks.
See you tomorrow.
See you tomorrow.
Great workshop. Yeah.
See you tomorrow.
Great.
Thank you.